And good afternoon, YouTube. Just got a new shipment of our Toyota ball joint spacers in. So anyway, I've got 350 of these. These are what we call our four-wheel drive ball joint spacers. And then we also got 150 of our two-wheel drive spacers. And what these are used for is they're an inexpensive suspension lift for Toyota pickups, 4Runners, P100 pickups, the Hilux Surf. So the way these work is you've got your upper control arm. Normally your upper ball joint would mount directly to that, but we make these spacers. You put the spacer between the upper control arm and the ball joint on the bottom. I'll cut in a picture right here so you can see one of these installed. On the four-wheel drive, the ball joint sits in the middle of the four bolts, and there's actually a hole in the control arm. The two-wheel drive pickups, the ball joint hangs out over the end, kind of like a diving board, so your ball joint sits out here in this area. And so what we do for the two-wheel drive pickups to beef that up a little bit is we also have this upper control arm brace. So this is a 1/4 inch 6mm bent steel brace that can attach to the top of the upper control arm to just beef it up a little bit. You use the mounting bolts that hold the ball joint, go through these 4 holes, and then you can drill 4 new holes and put some small bolts in here and then attach the ends of this brace to your upper control arm. So that's the two-wheel drive. I've already got those unboxed there. And down here I've got 6 more boxes of these, which are the new four-wheel drive spacers. So I've got a bunch of these guys to unpack. When I get done, there will be 7 layers here. I get 50 parts on each layer. So these are all right out of the machine shop. This was the original design by Frank Falcone of San Diego Off-Road Innovations, SDORI. And several years ago, my company purchased the design and all the rights to this product from SDORI. So we now make these. They're designed in the U.S., machined in the U.S., and we ship them from the U.S. So this is all U.S. made. These parts are machined out of one solid piece of billet aluminum. They're machined on all sides. There's competitors out there that make these in cast aluminum, and the way you can tell, the billet part is about 16 ounces or 1 pound. The cast aluminum parts are basically the same size and shape. They weigh 13 ounces. So there's a 3-ounce difference. Either those cast parts are using some super lightweight like magnesium alloy, which is quite expensive, or there's air inside of here, because these are 100% solid aluminum. You know, there's no voids. They're milled out of a solid piece of metal, and they weigh 16 ounces. And if you get the same size part out of cast aluminum and it weighs 13 ounces, what is missing? So the cast aluminum parts likely have voids in there. They've got air inside of the cast metal, because that's the only way you can make a metal part like that lighter, is you got to put something in there that's lighter than aluminum. There are not many metals that are less dense than aluminum, so that's one way to tell. Our parts, they're fully machined. Even the two-wheel drive parts, you can see they're just solid metal. There's no voids in there. You can look through the holes. So these are all CNC machined. We get them machined in the U.S. And my job today is get this stack here about up to the top of the shelf. So these are the storage shelves I built a couple of years ago with the plywood stiffeners, and these really work well. I can load this up. This will probably be well over 500 pounds worth of metal parts there between the ones on the bottom there, and then I have the ones on the top, and then we've got the last of our current batch of parts up there on the next shelf. Okay, there we go. 7 layers of parts there. That's about 350 pounds of machined aluminum on that one shelf, and it looks like it's holding okay. I do need to secure this shelf to the wall. I've got to pick up some shelf brackets to mount them, but wanted to show you here is a little diagram of what these parts are for. So this is the front suspension of a 86 through 95 Toyota pickup or 4Runner, also the later model T100s, and then overseas you've got the Hilux and Hilux Surf, which use this same torsion bar front suspension up into the 2000s, I believe. The way this works is you've got this torsion bar here that runs along the frame rail. The torsion bar is like a spring, except it twists. Instead of compressing like a coil spring, it twists, thus the name torsion bar, and it goes through the upper control arm. And so that upper control arm, as it goes up and down, it twists that torsion bar. So when it's at normal ride height, there's a certain tension on the bar, and then as you go up, you're twisting that torsion bar, putting more tension on it, and that's what gives you your suspension. So those control arms just move up and down, and here in the back there's actually an adjuster, so you can preload that torsion bar by giving it a little bit of twist, and that's where these ball joint spacers come in. So here's your upper control arm, there's a lower control arm, your front steering spindle connects between these two ball joints, and then the steering spindle fits in between those two, and that's where your front wheels steer. And right here, this is the upper ball joint, and that's where this spacer comes in, is you can put this spacer between this upper control arm and the ball joint. What that does is it pushes this spindle down by the thickness of that spacer, which is 1.5 inches. We make these all the way down to 1/2 inch. We do 1/2, 3/4, 1, 1 1/4, and then 1.5 inches, which this is about 38 millimeters. So what that does, by pushing this spindle down, your frame of your truck is attached to this upper control arm. So if you move the spindle and the wheel and the tire down 1.5 inches, that tire is still on the ground, so that actually raises the front of the truck up by the thickness of that spacer. And then, being that this torsion bar is adjustable, you can raise or lower that torsion bar preload. So you can go anywhere from 0 lift all the way up to 1.5 inches, maybe 2 inches of lift, just depending on how you adjust that adjuster. But by putting this spacer in here, you keep the upper control arm horizontal. The bottom control arm is pushed down a little bit because you've got that spacer in there. So now you can go down like you did before, and you can go up like you did before because you haven't had to tighten up the torsion bar. So that's where these spacers are really nice. They give you the suspension lift without ruining your ride quality. On these two control arms, there's bump stops that limit how far up and down the suspension goes. The upper control arm has a bump stop that it hits when it goes down too far, Likewise, there's a bump stop on the lower arm that limits how high up it can go. But if you put one of these spacers in between, you're spreading the control arms apart a little bit. So now you can still go down till the upper arm hits the down bump stop, and you can still come up until the lower arm hits the up bump stop. So you actually get more travel as long as you don't tighten this torsion bar up too far. So if you're looking for a fully machined billet aluminum ball joint spacer, we've got them in stock. We can ship them right away. I'll put a link to our web page over here on the left side if you want to find out more about these parts or order them. And if you have any questions, go ahead and post up down in the comments section below. And as always, thanks for watching.